let's turn to some other landscape elements and how we view them as draftsmen. When we think about water, we're automatically thinking liquid strokes. What makes a liquid stroke with our drawing tool? It's the concave shape. Remember that bulging convex shapes describe earth and living forms. The concave stroke describes water. The ocean is made of a series of these strokes that follow a perspective by appearing smaller and flatter in the distance and larger and more concave in the foreground. The interval between the strokes also follows the same pattern. Now, the pattern that the edge of a wave makes when it breaks onto the beach can be either convex or concave, and the white caps at the top of the wave follow the convex bulging shape. The anatomy of an ocean wave is a triangular shape with a broad base and a narrow top. The broadness of the base prevents light from passing through the wave and appears darker than the surface of the water. The top portion of the wave is relatively thin, and light passing through it will create a light value at the top, but not as light as the frothing white cap on top. Seawater rushing onto a beach experiences a gradual change in depth. This is represented by a change in value from darker in the distance to lighter in the foreground near the sand. The light passing through the shallow water strikes the sand underneath and is reflected back up through the water. You can see this effect here, from front to horizon and from right to left. Sometimes it's better to see it in grayscale because color can confuse the issue. For this coastline, there is no beach. The water is deep and bangs right up against the sheer rock coastline. This creates just the opposite effect from the one we saw in the preceding example. Deep water in the foreground appears darker than water at the horizon. This is obvious when we view it in grayscale. The reason that the water is dark up close is that there is nothing close enough to the surface to reflect light back up into our eyes. On the other hand, the water out in the distance becomes a giant mirror, reflecting a lot of the lighter sky value back into our eyes. It doesn't appear as light as the sky because the motion of the water, even in the great distance, causes it to be darker. Our angle of view plays a part in creating the value relationships by being able to see into the depths up close and not being able to see under the water in the distance. Another type of waterway is the shallow brook. As you can see from this illustration, the water is noticeable only as a change in color and a few flecks of reflected bright light in the distance. If we were drawing this brook, there would be virtually no way to indicate it differently than the ground, except the concave versus convex stroke. The value certainly couldn't provide any identification of what it is. In grayscale, it looks like a wooded path and no more. So in scenes like this, color would be mandatory to fully explain what's going on. Now this stream of water is fast-moving and much deeper than our shallow stream, and we're viewing it from a high vantage point, allowing us to see down into the depths of the water. Because of the speed of movement and the depth, almost no light is reflected back from underneath the water, so it takes on a dark value relative to its surroundings. The light values seen on the surface are much darker than the sky colors and values seen directly overhead. The water in this calm river looks almost like ground because its muddy color is so obvious. This is because of the way the light is striking it relative to our view from this side of the river. On the other side of the same river, looking back across, the water presents a whole different viewpoint in value and color to the viewer. Although this scene is on a river, it's behaving like a still pond with the clarity of the reflections. This brings us to a unique part of drawing water. It often provides a whole other area of interest in the form of reflected images from above. There are some things that you should look for as rules of thumb when painting reflections. First, notice that the value of the light objects are reflected darker. The White House is much lighter in value than its reflection, and the detail in the ivy with respect to its color is totally lost in the reflection. Also, notice the value of the sky reflected in the water. All the values in this reflection are dark because of our angle of view. We're looking down on the whole scene. Our eye level is even with the top windows on the red ivy-colored house, because we're pretty high up on the riverbank. As a result, we're seeing down into the depths of the water, which is causing all the reflected values to be quite dark. In this scene, we're standing on the bank of the water. The reflections of the trees are overall darker than the values above. The reason for this is the surface of the pond acts like a mirror. Imagine a mirror right next to the opposite bank. What would it see? Would it see the top surface of the trees we're looking at? No, it sees the underside of the foliage, and that side, the interior of the foliage, is always in shadow, even on the sunny side. Notice something else. The lower edge of the reflection is broken up by the surface movement of the water. This may be the only way to indicate the water surface, but it is an important one. Also, the contour of the reflection of the treetops is diffused and soft. Never reflect an exact duplicate of what is above. At this angle of view, you'll notice that the length of the reflection is the same as the height of the trees. That's because the water is so still. If a breeze came up and the water started to move on the surface, you would see the reflections lengthen toward the bottom of the canvas. If the surface became choppy, all the reflections would disappear. Notice that there are no light highlights at the water's edge on the distant bank. The ground is light, but there are no glints off the surface of the water. I've seen painters put those in whether they were there or not. On a still day like this one, there would be no reason for a highlight at the water's edge. Be truthful to the scene, and it will have authority in your paintings. Look at the reflections of these boats in the water. In every instance, the reflection is darker than the value of the boat. Well, what about dark-colored boats? When we see a very dark object, its reflection will be lighter in value than the object, as with this boat. Depending on the angle of light and our viewing angle, the values of the reflections could range widely, but you can safely conclude that the values in the reflections will never be as great as the values they are reflecting. So what have we observed about reflections? First, light values are reflected darker. Dark values are reflected lighter. In still water, reflections are the same length as the object being reflected. In moving water, reflections will be longer than the object being reflected. The edges of reflections are diffused because of the moving surface of the water.